So we've had a look at a couple of examples of doing first principles. This example just takes it one step more, more complex in the fact that we're not just working with just any kind of fraction, any function, but we now have a function with a fraction in it. So yeah, definitely seeing this being asked quite often. So something you want to definitely make sure you are getting your head around. Okay. All right, so they've asked us to find the derivative if f of x is equal to 1 over x squared, and obviously it's by first principles, so we're having to follow the whole process of first principles. Okay, so in order to do that, let's just move up my screen here. The first thing we're going to do is we're going to write out our first principles formula. That's always your best starting point, and that's f prime x equals the limit as h tends towards 0 of f of x plus h minus f of x, and it is sitting all over h. Let's just, no, never mind. Okay, right, so we're going to say equals limits h tending towards 0. If this is f of x over here, then f of x plus h, do you agree with me, would be 1 over, where there's x, I'm now replacing it with x plus h squared, okay? So just be careful and be neat here because you're working with fractions over fractions, okay? So you just need to just make sure it's being set out nicely. So f of x plus h is the value of 1 over x plus h, and that is being squared, minus f of x. Your original f of x function was just 1 over x squared. Okay, now I'm going to change the color here, and I'm going to say over. So here's my over line. Okay, and then we're going to go back to over h, which is sitting over h. Okay, so I've got my equation set up. Now we have to do all the tidying up work. Okay, can you see that I'm writing limit as h tends towards 0? Remember with your lessons of limits, we only substitute the limit into the values for h at the point where h is no longer going to be undefined. So remember, the whole idea here is needing to get rid of the h in the denominator. Okay, so I need to find a lowest common denominator. Okay, so LCD in the numerator part, I'm needing to find an LCD, which, look at what I've got here. I've got an x plus h squared and I've got an x squared, and basically that's your LCD. Okay, so you've pretty much got an x squared as well as an x plus h squared as your LCD. Okay, which means that this 1 over here is getting multiplied by just x squared, and this 1 over here is getting multiplied by the x plus h squared. Okay, so 1 times by x squared is just x squared minus, and then this is going to be 1 plus h all squared. Okay, and it is all over, let's do it in red again, it's all over the h underneath it. So again, there's your fraction of your fraction part of it, so just sets it out neatly. Okay, equals limits h tending towards 0. Okay, now our next thing is that we need to FOIL that out. Okay, we need to make sure that we get all those brackets gone. So x squared minus, please make sure that you keep this part in brackets because the negative needs to distribute into it. X squared plus 2xh plus h squared. That's our FOILed solution, right? That's over. It's over the LCD. Remember, the LCD was x squared, x plus h squared. Okay, and it is all over. It's all sitting over. So let's do it in red again. There, all sitting over h. Okay, all right, so you can clearly see by the red line, and maybe this is something worth doing when you're actually doing a sum like this, is use a different color to indicate the divide line between your numerator and your denominator. So we've got our limits as h is tending towards 0. And our next step is that this negative needs to distribute. So x squared minus 2xh plus h squared. That is over the LCD. The LCD, oh no, we don't want to do that. The LCD, which was x squared, x plus h all squared. And over, okay, so there's our divide line, and it's all over h. Okay, no, sorry, let's get back to our blue. Oh no, now I've changed my red line. Anyway, okay, leave it for now. Okay, there we go. Okay, right, okay. And we've got our limits as h tends towards 0. I know it's painful, but you have to write it every single step of the way, so don't skip that out. X squared and x squared cancel each other out nicely over there. What else can I do? Nothing else really. Okay, so here I think is the point to which let's get rid of this. Let's deal with this divide line over here, this red divide line. If I've got a fraction divided by another fraction, well, remember what we do with dividing fractions is we tip and times. So let's show you how we're going to write that. So negative 2xh plus h squared, which is over the LCD of x squared, x plus h all squared. Okay. And I'm going to say multiplied by, now if this denominator was h over 1, if I tip and times it, it's going to become 1 over h. Okay, that's going to work nicely because if I take out a highest common factor of h from here and from here, all right, we're left with negative 2x plus an h over, we've got x squared, and I've got x plus h squared, and then times by 1 over h. I know it's a bit of a long story, but we will get there. Okay, so those guys cancel out. Right, so that's gone. Now we go back to where we've got limits. We've still got the limits. I'm not ready just yet. Let's just see what we've got now. We've got a negative 2x plus an h, and it is sitting over an x squared multiplied by an x plus h squared. At this point, if I substituted h with 0, it's not going to be a problem because it's not going to land up making the denominator 0. So at this stage, do it. Substitute. So everywhere there's an h, substitute your limit where h was tending towards 0, okay? Which means I'm going to write equals, and I'm not going to write limits anymore. I'm just going to plug in the limit of 0. Okay, so we've got x squared multiplied by x plus 0. Okay, and let's see what that gives us. So negative 2x is what we have in the numerator. And in the denominator, x plus 0 is obviously just x. X times x is x squared. So actually I'm sitting with an x to the power of 4 down in the denominator. And there's one final thing I can do over here, and that is that my x at the top will cancel with one of the x's at the bottom, leaving me with an x cubed. And therefore we have got negative 2 over x cubed as my derivative. And remember, your notation for derivative is your f prime x. Okay, so yeah, quite a lot of working out. I think that would be worth a fairly serious amount of marks, but as I said, I've seen them being asked. It's definitely one of those ones that, yeah, just if your teacher's wanting to push you a little bit in your understanding of it, that's a good way to do it. So make sure that you do it when you do it yourself. Make sure you've practiced it and keep it neat. Use rulers. Make sure you keep it neat because this can get untidy very quickly. All right. We will see you in the next video. Keep it up. You are doing really well. See you now.